So let's take a look at loading Splice data from JANUS. So this is going to be the older stuff. And the first thing we want to do, let's see. Here we go. We want to open the includes Splice data loaders from the includes folder on your hard drive. Give it a double click. Compiled itself. And we don't need this guy anymore. All right, let's get some data. Oh, let's go here. Here's the new menu. And you'll notice because this is JANUS is for the older data, we can't use the U1338 that we've used in a lot of our demos. So we're using U967, which is from the Eastern Mediterranean, if you're interested. So let's go. We want to get some data. So here's the JANUS website. We'll go to stratigraphy splices. It's leg 160, site 967, and as you can see, we have splice intervals and splice tie points. And I'm going to show you in just a second that the splice interval data have a serious error, and don't use it. So let's go to splice tie points first. Here we go. We'll submit our request. And here is our splice data for 967. Let's copy it. Control C. Okay, that here. Let's go up to Splice Loaders and do an empty JANUS data table and paste in the data. Now, the core type is listed twice in the in the data. It must be down here somewhere. But we don't actually use it anyway, so just delete it and load them up. Okay, here we go. Now notice the first section is from hole D, and it goes from the start to 6.26 meters. So that's the first section of the spliced column. And it ties to hole A. And I've checked these against the initial reports volume, and these are correct. Okay, so let's go up to Splice Loaders, and we want JANUS Splice Tie Loaders. Because there are a number of errors in these older tables due to maybe transcription or whatever, these routines actually take the CSF depth and recalculate core section interval. And it uses the CCSF as well, just as a check. So if there are no CCSF values, you'll get an error. In this case, 967E was a bad hole, and there were no offsets, and we can just skip this. Okay, now because we are calculating core section interval from the CSF depth, sometimes because of overlap, you'll see more than one core section interval for a particular depth. So you can just say OK, and that's just a little buggy thing. Okay, so here is our splice tie table. Let's make it out. Just about takes up the whole thing. And here you see we have D1 starts at the top, and then we goes to 6.26, and just as we saw, of course. Now, one thing about the JANUS data for ties, one adjustment that you have to make. The way these tie tables work is the top of an interval is actually listed over here and the bottom here. So you can see this is actually at 6.26. So here is the top of the last section, but we don't have data for the bottom of the last section, which should be over here. How do we fix that? Copy this and paste it here. Okay, so the last section is from B13 194 to the bottom of B13. So we need to figure out where the bottom of B13 is. How do we do that? And it's not very difficult. Let's just put him here. Now let's get the B coring matrix right here. Okay, so we're looking at B13 right there. So the bottom of B13 is going to be section 7. We'll go up and do that. The interval of the bottom of section 7 is going to be essentially the length of section 7, or 60 centimeters. So the interval, 60. The CSF to the bottom, or MBSF, is going to be the depth to the top of the section plus the length. So 119.4 plus 0.6 is going to be 120. And in the same manner, the depth, the CSF or MCD depth to the bottom is going to be 130.8 plus 0.6, or 131.4. So there you have it. Now we go up to Splice loaders, and we don't do anything. Anyway, there's our Splice table. Well, actually, let's leave that open for a second. Okay, now back to JANUS. Let's take a look at Splice interval. And here's the problem. You can see in the Splice interval, they're saying that the interval from 0 to 6.26, which we see right up here, comes from core A. And it doesn't. It comes from core D. And in fact, I've run across this problem a number of times before, as a matter of fact, every time. And what's happened is they've missed out on the first hole. So everything is offset. If you did for some reason want to download these data, you'd need to insert a D up here. Then these numbers would all be in agreement. Although you wouldn't get quite as deep, 122.4, as this one, which winds up at 131.4. So my strong suggestion is just don't use the interval data from JANUS. If you want an interval table though, and Splice interval tables can be very useful, just go up to COD data or COD image to Splice format conversion, and we want to do a Splice tie data to intervals. Now it says if we already have a shared folder of Splice interval data, running this routine, this function will break that link. So we don't care, we don't have one. And it's 967. And here is our Splice interval table. So now you can see D goes from 0 to 6.26, and A, and so on and so forth, down the line to B, which goes from 122 to 131. So there you have it. These data that you just loaded or converted are kept in new folders on in your data browser. Here's the Splice intervals, and here's the Splice ties. Okay, so in another video we'll talk a little bit about the difference between Splice intervals and Splice ties, very briefly, and then we will go into adding, splicing data again in separate videos. That's it.